All right, you guys. So for number 2, we have that the value of a car is given by this function, where t is in years since the 1st of January of 2023 and c is in USD. Now let's take a moment to really understand that. So because t is in years since the 1st of January of 2023, that means that if you plug in, for example, a t of equals 0, it's going to be the value of the car at the year 2023. If you plug in a t of equals 1, it means you're looking at the value of the car in the year of 2024, and so on and so forth. Okay? And so that is how you sort of interpret when it says t years since that amount, right? And so like your year 0, if you want to think about it, your year 0 is 2023. Anyways, for part A, you're going to write down the annual rate of depreciation of the car. Now this, from a visual standpoint, is very, very easy. You can just look at the function and immediately say, for part A, it's just 9%, right? Now let me take a moment and really explain why it's 9%, because I know this can seem, kind of weird, kind of whatever, right? And so the reason you sort of reach 9% is because next to your 40,000, and this is a classic sort of function, so you can get familiar with it. Next to your 40,000, you have a times 0.91. Now think about it. If you take a number, right? Uh, I'll use 40,000. Why not? So if you take 40,000, and this is the main idea I need you to understand. See? Imagine you multiply it by a number greater than 1. If you multiply by a number greater than 1, what do you think is going to happen? So let's imagine you do 40,000 times 1.5, right? Or an even simpler idea. So greater than 1, you multiply by 2. What do you think is going to happen? Well, instead of 40,000, you end up with 80,000, right? Pretty straightforward, right? So it gets bigger. So anything greater than 1, it's going to be bigger, right? And over here, if you take 40,000 and you multiply by anything less than 1, for example, 40,000 times 0.5, that's half, right? And so you actually end up with 20,000. So by multiplying by something less than 1, you end up with something smaller. Okay, so this is pretty straightforward. You multiply by something greater than 1, it's bigger. You multiply by something less than 1, it's going to be smaller, right? And so up here, immediately you can sort of notice it's being multiplied by a number that is smaller than 1. So 1 is greater than 0.91. And so, we're in the situation where our number will be getting smaller. So that's also why we're talking about a depreciation. Now, a common mistake that occurs here is that a lot of people see the 0.91 and say, okay, it's depreciating by 91%. Now, if something were depreciating by 91%, let's take a moment and really consider that. See? Imagine you have a phone and per day it depreciates 91%, right? So on the first day it's brand new. How do you think it's going to look on the second day? Dude, on the second day, it's going to be all messed up. It's going to be filled with cracks. It's going to be filled with these iTunes updates and stuff that just make your phones like slower. Like, it's going to be filled with a bunch of stuff like that. See? And so this 91% depreciation that you're assuming just because it says 91 is a small mistake. Think about it this way. If it actually were 91%, then the value of the car would go from 40,000 to a really small number. But if you take this 40,000 and you multiply by 0.91, it's still pretty close to 40,000, right? And so there's no way this is a depreciation of 91%. It's actually the other way around. You're depreciating by 9% because that is how far you are from 100 or from 1. If you wanted to depreciate this by 91%, you would actually take the same number and multiply by 0.09, right? Now let me explain for a moment how I actually got those numbers. So if you want to depreciate it by 9%, that means you're taking 40,000, I'm multiplying it by 1 minus 0.09. Because this way, it ends up being a depreciation because, now you end up with a number smaller than 1. And to make it 9%, you do by minus 9%. Now, a percent as a decimal, you're just going to move the decimal twice. For example, 5% is just going to be 0.05. See? 50% is just going to be 0.5. Okay, so be wary of how that works, right? So 9% is going to be 0.09. So if you subtract over here, you end up with 40,000 times 0.91, right? And so that is what's happening behind the scenes. To depreciate by 9%, you do 1 minus that 9%, right? And so if you want to depreciate by, I don't know, I'm going to make it up. See? Imagine you want to depreciate by, just to so that we're on the same page. So depreciate by 33%. See? That means you're going to be taking your 40,000 and multiplying it by 1 minus 0.33. And so how your function actually looks like if it depreciates by 33% is 40,000 times 0.67. That is how it would actually look like. See? And just one last example, imagine it's not depreciate, but it's instead, for example, growth. So let's say it's growth of 12. So growth of 12%, on the one hand, we already learned that if you put 40,000 times 0.12, well, you end up with a smaller number because you're multiplying by less than 1. And so in this case, if it's growth, there's no way it's going to be 0.12, but it will be 1 plus 0.12. So it's going to be 40,000 times 1.12, okay? And so there we learned how depreciation and growth and all that stuff works, how growth and decay works. Main idea is that if it's going to be greater than 1, I mean, if you multiply by something greater than 1, it's going to get bigger, so it's going to be growth, right? And if you multiply by something less than 1, it's going to be smaller, so it's going to be decay. And what's the actual process or the step behind the scenes? It's this one right here, okay? So you take that 1 and you do minus the 9%, or for growth, you would take 1 and you do plus that 12%, okay? So anyways, that was a little bit of a longer explanation of growth and decay, but at least now you're ready for anything that you face. And so that was a long explanation for part A, but I'm sure someone out there appreciated it. So the annual rate of depreciation of the car, you can just sort of put your proof like this. I think this is good enough, okay? It leaves very clear that you understand where the 9 comes from. And so your answer for part A is 9%, okay? For part B, you need to find the value of the car on the 1st of January of 2028. And this is also easy points. It just has to do with interpreting your function correctly. And so remember how we said earlier that t equals 0 gives you the year 2023? Because t is, I'm careful, t is years since the 1st of January of 2023, right? And so if you plug in t equals 2023, you're actually looking at the year 2023 plus 2023, okay? If you plug in t equals 2024, you're actually looking at the year 2023 plus 2024. So it's a lot of years down the line, right? And so in this context, that's what's important. In this context, they define t as the amount of years since the 1st of January 2023. So if they're looking for the 1st of January 2028, well, how many years is between 2023 and 2028? It's 5 years, right? So you can do 2028 minus the 2023, you end up with 5. And so that means that your t has to equal 5, and that will be the value of the car, right, that you're trying to find. And so if you go ahead and plug in t equals 5, that means that you should be putting into your calculator 40,000 times 0.91 to the power of 5. And so let me show that on the calculator real quick. So 40,000 parentheses 0.91 to the power of 5. So bada bim, bada boom, there is the value that I'm looking for. See? And so for part B, the value of the car ends up being 24.961 at 2858. 0.2858. And so that is for part B. And last but not least, and this is the more like intense part of the problem because, hey, look at that, it's worth 3 points. Now we have our good old friend Alvi. And so Alvi, for some reason, wants to buy this car that showed up on a math problem. And so on the 1st of January of 2023, he invested 15,000 in an account. Okay, so this is already this part is filled with buzzwords. Okay, so let's go piece by piece. On the one hand, he invested 15,000 in an account that earns 3% annual interest rate. All right, so 3% annual interest, and careful, it's compounded yearly. Okay, I'm putting this in a different color because it's right next to another buzzword. These are two separate buzzwords. Yeah, he makes no further deposits. This is actually also important. So no further deposits. Let me highlight the important part. So it says no further deposits to or withdrawals from the account. And so good old friend Alvi wishes to buy this car from the math problem for some reason for its value on the 1st of January on 2028. And so this is also key for its value, on the 1st of January, blah, blah, blah. In addition to the money in his account, he will need an extra M. And so find the value of M. So a little bit of context. So for part C, all right, so for part C, our good old friend Alvi, this is what he's doing. He is saving money for 5 years. Then buys car with money saved plus M. Okay? And so the money he saves for 5 years is not enough to buy the car. And so that is why they ask about finding the value of M. The value of M is the extra amount he needs because the amount of money he earns by saving is not quite enough. See? And so for part C, the procedure is actually very straightforward. Now, I really need you guys to understand the procedure and the formula and like the thought process, okay? At the end of the day, what I try to explain the most in my videos is the thought process that goes behind all of this, right? And so if you take a closer look at what's going on, you find all these buzzwords. You find annual interest, you find compounded yearly, you found an initial invested amount, then you find an initial end amount later down the road, and this and that, and blah, blah, blah. It should be ringing a bell that we're talking about compound interest, okay? And so once you identify, this is a compound interest problem because I have an initial amount, you have compounded yearly and all that stuff, you can go to your formula booklet and scroll all the way down until you eventually find compound interest, which is right here. And so take a look at compound interest. Compound interest asks for your future value, right? Your present value, the number of years, the number of compounding periods per year, and the nominal annual interest rate. And so compound interest is something that you can use and it works. And this is something that I need to clarify. It uses and it works when you don't have PMT. Okay? And this is something that you need to leave extremely clear. All right? You have two main tools for this. You have the compound interest and you also have the finance app. Okay? And this is the main thing that you can sort of like get from this. Compound interest is when you don't have PMT, and finance app is what you use when you have yes PMT. Okay? Now, having that in mind, you can use the finance app when you don't have PMT. Like you can also do that, and I'm going to show you how. Actually, this is going to be a very complete video on showing both approaches. But the main idea you really need you to understand is that whenever you have PMT, you're going to be using the finance app, period. Now, I'm sure there's at least one of you thinking, what the heck is PMT? And so PMT, I forget like what it stands for, like the P, the M, and the T, but I know that it's monthly payments. And technically, it's sort of like an additional monthly payment, right? And so, for example, over here, our money is getting compounded yearly, right? And so, because he makes no further deposits or withdrawals, then your PMT equals 0. But some of these exercises say like, oh, and Alvi also puts an additional money like every month, right? That additional money would be a PMT of whatever value they give you. So if Alvi for some reason would put an additional $300 per month so that you know it compounds faster or whatever, then yeah, I mean PMT would equal 300. But in this case, he makes no further deposits, no withdrawals, no nothing. PMT equals 0. And so because PMT equals 0, you can just use the compound interest formula and forget about it. Now, I'm still going to show you how to use the finance app because I think it's very important to understand this tool, especially for when you face PMT. But for now, I will initially show you the compound interest formula. And so the compound interest formula, as we saw earlier, first let me make a little bit of space because we will be writing quite a bit. And second of all, keep in mind that the compound interest formula, it asks for 5 things. And so the 5 things that it asks for are, it asks for FV, PV, and K and R. So first let me write down the equation real quick. So we have FV equals PV times 1 plus R divided by 100K, parentheses, K times N. And so the cool thing about these compound interest problems, especially if PMT equals 0, the cool thing that happens is that they give you almost all of these. See? What do I mean by this? The approach is always the same. You have FV, you have PV, you have R, you have K, you have N, right? And so go ahead and define each of these one by one so you can plug into your calculator more easily. And so let's go piece by piece. Here, if I read from top to bottom, they say that, let's read it again, like with the context we know. So Alvi wants to buy this car that he saw in this math problem and he thinks is real. On the 1st of January 2023, he invested $15,000. And so his initial investment is $15,000. And here is already something very important I'm going to tell you. This, I suggest you think about it as the POV of our good old friend Alvi. And so if this is from the perspective of Alvi, his initial investment, he put it into the bank, right? And so does he lose money initially? Technically he does. Technically his initial investment was losing 15,000, right? I mean, he's putting into the bank, he's getting money back, but this is important. Okay, your PV in the context of an investment, and I suggest you always do it this way. So in the context of an investment, the PV is initially going to be negative because, oh, Alvi is taking it away from his pocket, and his future value that comes back to him is going to be positive. Okay, so think about it that way. I think it's way more convenient to approach it like that. See, and so your PV is going to be negative 15,000. Your FV is going to be positive because it's an investment. He initially loses money because he's giving it to the bank. He's losing it from his wallet. See, he's going to get back way more, but initially he loses it from his wallet. Negative 15,000 PV. Just trust the process. Recognize it's an investment. See. Then they tell us it's a 3% annual interest. And so which of these values was for interest? R percent is for annual interest. So there it is. So R is going to be 3, right? So 3%. And well, R is already in percent, so you can just leave it as 3, right? Perfect. Then K we said was number of compounding periods per year, right? And so this, let me just explain real quick. You can have yearly. You can have, for example, I don't know, monthly. These are like the common ones, right? So if it's yearly, K is just going to equal 1. Because how many times, if it's yearly, how many times does it compound per year? Well, there's 1 year and 1 year, right? So K equals 1. For monthly, there's 12 months in a year. Maybe you might encounter bi-monthly, which is every 2 months, right? And so K would equal 6. I guess you could also face semesterly. I've seen it very seldom times, but I guess semesterly would be K equals 2, like twice per semester. I mean, 2 semesters per year, right? But yeah, those are the main things that can happen to you. Those are the buzzwords that you really need to keep in mind, okay? Anyways, in this case, yearly is our context, so K is going to equal to 1. And then N, we said, is the number of years. And so for how long good old friend Alfie is storing his money, his or her money. So sorry. So N is going to be 5. Because Alvi wishes to buy this car for its value on the 1st of January of 2028. How many years later is this from the initial investment? Well, it's the same as before. So before we were comparing the value of the car in 2028 when it started in 2023. And in this context, Alvi wants to buy the car in 2028 and is initially investing in 2023. And so the same approach is happening. You're doing 2028 minus 2023, and you find that the distance, I mean the amount of years is 5, so n equals 5. See? And so boom, look at that. The one variable I have is FV. So your FV is some positive x. Okay? So if you go ahead and plug all of this into your formula, what you end up with is some x equals this negative 15,000, parentheses 1 plus 3 divided by 100 times k. K we said was 1. And then up top you have k times n, so it's going to be 1 times 5, right? Now 1 times 5, I'm just going to leave it like this. See, I could simplify it a little bit, but honestly, you can just plug all of this into your calculator and just go with the flow. See? So if you plug all of this into your calculator, you can do negative 15,000 times 1 plus 3 divided by 100, and all of this to the power of 1 times 5. See? And so that gives me negative that amount. See? Now, and here's a disclaimer I should have done earlier. The symbols over here, I should have said this earlier, but now that it showed up now, even better. See? The symbols that I chose here is more for like the finance app. This is much more for the finance app. See? In the context of just using the compound interest formula, the negatives technically don't matter. Like you would keep this 15,000 positive, right? And this would make a lot more sense. So your FV is going to be 17,389. And so for the context of the formula, I should have said, right? So for the context of the formula, the positive and the negatives don't really matter. So you can just leave it like this. And so your X or your FV ends up being, or FV ends up being 17,389, right? Let's just put the whole number. So it would be 0.11111, right? So this is your FV, right? And so for the finance app, the positive and the negative matters. For the compound interest formula, technically you just keep it all positive. It wouldn't make sense to put it negative, see? Now for the finance app, it is relevant that you do the perspective of ALVI. And for an investment, it would be a negative PV because you lose money initially and then a positive FV down the road. Now, a quick disclaimer, if you look at the answer key, the PV, they put it in a symbol like this, see? And so what this is saying is, notice this symbol shows up in two places. It shows up here, right? And that's not very highlighted as I would like it to be. So it shows up here, and it also shows up here for FV, right? And so what this is basically saying, because they're inverted versions of each other, it says you either put a positive PV and a negative PV and a positive FV, which is what I suggest, or you put a positive PV and a negative FV into the finance app for this to work, right? And so this is for the finance app, see? Now for me, in an investment, it makes a lot more sense if I think about it as you first lose money and then you earn. So that's why I put PV negative, right? Technically, there's a way to think about it where PV is first positive and then FV is negative. To each their own. I suggest a lot more this version, see? But enough blah blah. Let's see how this looks in my calculator. And so if I go over here and go to the finance app, I first press apps, then I press finance, and then you're gonna go to the TVM solver. Okay, so if you press the TVM solver, you're gonna realize that a lot of what it asks for is basically the same as the compound interest formula. There's just one or two things I have to point out. Okay, the first thing is that n over here is really, they leave it as big N. Okay, and I need you to understand the following. Big N in the finance app, there's a couple different ways to define it. If you look at different mark schemes, big N sometimes changes, but the approach that I suggest that will always work is that big N is going to be K times N. Okay? And this is the kind of thing that, just trust me on this. I know I'm a guy on the internet, but at least for math, you can trust the guy on the internet, at least hopefully, right? So trust the process. Big N is going to be K times N. And if you choose for big N to be K times N, then that also means that PY and CY are both going to equal K. Right? In my experience, this is like what ends up happening. If you choose big N to be K times N, then the PY and the CY at the bottom are just going to be K. All right, so this is way more easier, in my opinion, to understand than if you start having different PYs and different CYs. All right, I don't recall exactly 100% how PY and CY worked. I'm pretty sure it was like periods per year and then compounds per year and something weird like that. But at the end of the day, what I'm trying to tell you is that of all the procedures you can choose, of all the big N's approaches that you can do, I suggest you leave it like this. Okay, so big N is going to be k times n, and that allows you to have py and cy equal to k. And so if you consider that, well, big N is just going to be 1 times 5, which is really like this up here, right? And so for big N, you're going to leave it as 5. For the I percent, it's the same as the R. Okay, so this is your I percent. All right, so you're going to go ahead and put this as 3. Your PV, we said, was an investment, so your PV, we're going to think about it as first losing money. So first you put money into the account, you lose 15,000 initially. PMT equals 0 because there's no further deposits. They don't say anything about some random monthly deposit. FV is what you're trying to find, so you're going to leave it like that. And then PY and CY stays as 1 because we said that PY and CY is going to equal my K. Yeah? So I need to leave really clear, you guys. You can allow PY and CY to equal to K because you're choosing your big N to be K times N. All right, there's a whole different approach, which I do not know well, so I don't want to get into it. But basically, if you choose big N to be just N, then your PY does not equal CY. And there's a small specification that you need to keep in mind, which I do not remember. And I would much rather have you remember what I think is much more straightforward, which is this guy up here. See? So just in case in class you might see that big N equals N, pay attention to your teacher. The procedure is a little bit different. It still works. There's a lot of different methods. The method that I suggest tends to be the most intuitive one. And I think the most intuitive one is the one I mentioned up here. See? So again, a lot of blah blah, but I need you guys to understand as well. I need you guys to understand what is going on and why. To truly understand something on a deeper level and to really manage knowledge wisely, you need to understand why. Never stop asking why things are the way they are. It's the best way to really learn something and understand it. Okay? So I got a little bit of philosophical there, but never stop asking why. See? True education is not knowing what to think, it's knowing how to think and why. See? Doing it's justifying your approach and stuff like that. See? So learning how to think is more important than knowing what to think. So the how to think is this. This is a procedure that I suggest. It just kind of makes sense. See? All right, whatever. So anyways, from here you can now solve for FV. Now, how do you solve from FV from here? Well, there's this little solve button on your calculator on the bottom right. So the bottom right is enter, but in green, you might be seeing this button that says solve. And so if you press alpha enter, you're going to be hitting that solve. Now it's important that you stand on top of FV. And so basically, if you solve from here on FV, you're asking your calculator, given all these parameters, what should FV be? And so basically your calculator takes a version of the compound interest formula, right? It takes a version of this, maybe with a PMT in between because you might have it, and it solves for one of the variables that is alone. See? And so if you go ahead and press solve here, so alpha enter, it gives you the same value. So look at that. I just showed you 2 ways to solve the same problem. I might as well give you more tools to your toolkit. See? So that is most of the part for part C. See? And so what we just found is that he was first saving money for 5 years and then buys a car with the money saved plus M. And so the money saved, we just discovered, like once again, we just discovered that it's 17,389.11. And so this plus M has to equal the value of the car. Now, what was the value of the car? Well, they tell us that he wishes to buy this car for its value on the 1st of January 2028. And what is the value of this car on the 1st of January 2028? That is what you did from part B. So lo and behold, another thing I can sort of teach you quickly, whatever you do in part C usually needs something from part B. All right? It's not always the case, but it can be a very big hint on how to move forward. See? And this also tells me that even if what you got from part B is wrong, if you use it in part C, it's going to get you a point. And that is also very important to understand. See, maybe the value of the car you got doesn't make sense. Maybe it's a negative value. Maybe it's like it's way off, and you know it's way off, but you're low on time and you're still gonna solve the problem. Just plug in what you got in part B into part C because they really care about method points. All right, and so method points from over here. Look at this. Look at that. Whatever you have, subtract their value from their answer to part B. That is a whole method point. And so part B can be completely wrong, but you still get a method point. Guys, I'm just pointing this out. See, you might not get an answer. I mean, a 1 point for getting the right answer, but you will get a method point for plugging in whatever you did in part B. You could plug in 0, but as long as you leave clear that your answer in part B is equal to 0, then they have to give you a method point. And so keep that in mind, you guys. Method is very important. That's also why I talk so much about formulas and procedure. See? All right, anyway, so from part B, you found that the value of the car was this. So 24,961 equals 24,961.2858. And so to get M alone from here, well, it's right next to a 17,000, so you can subtract onto both sides and see how much M ends up being. So this goes away with this, and M has to equal that 24,000. So it's going to equal the 24,961.2858 minus 17,381.1111. So let me double check that everything is plugged in correctly. Looks fine by me. Yeah. There it is. So M equals 7,580.1747. All right, and here, as you can see, it's a little bit off from the final answer over here. And so it probably has to do with something with decimals, right? And so for example here, just because I know there's someone in the comment section that's going to ask me this, see? So notice that for part B, you can leave your answer in two different ways. You can either leave it like the entire number, which is what we did, or you can leave it in significant figures, see? And so here we decided to solve everything using the entire number, right? So if you solve it using the entire number, and you also plug in for part C, here you use the entire number, right? So use the entire number or significant figures, you can either end up with one of the two answers, see? And so as long as you sort of like follow the procedure, everything should work out. And now that I take a closer look, there's actually a small mistake that I did, which is what actually happened. But I'm leaving it in the video because we all make mistakes. No one's perfect. Good thing I double checked. Over here for FV, I got a 70,389. And over here I plugged in 81 because I'm trolling. See? So, happens to anyone. I might as well leave it in the video because, yo, no one's perfect. So that should have been a 9. And so I do the same procedure but change this small thing to a 9. Good thing I checked. Now we end up with the right answer. So 7,572.1747. And this makes a lot more sense. 7572.17, right? So this makes a lot more sense. What I explained earlier is still relevant for me to mention. You can either leave everything in significant figures or anything with the entire number. See, so whatever you choose, stick to it. In this case, we chose the entire number. I could have done sig figs. How does sig figs work? You count 1, 2, 3, see if you round it up or keep it the same. In this case, you round it up, so you end up with 25,000. Down here, for example, you can say you count, well, for this final answer, for example, you can count 1, 2, 3. Do you round it up or keep it the same? You keep it the same, so it would be 7,570, right? If you want to do significant figures here, you would count 1, 2, 3. Do you round it up or keep it the same? You round it up, it would be 17400. See? So again, that's just a small difference that your answer can change slightly depending on putting the entire number or the significant figures. And in this case, I actually trolled because this 9 I turned into a 1 down here, and that changed my answer entirely. So everyone make mistakes. I'll leave it in the video because I'm just another human just like you. And yeah, that is for part C, and that is for number 2. A little bit of a long explanation, but also very in-depth in terms of compound interest and the finance app. So I hope it helped. And if you ever face PMT, remember it's just a monthly payment. You got to put it in. You got to use the finance app for that. You cannot use the compound interest. See? So yeah, careful with the symbols. Keep in mind that for investment, PV, ideally for me, you leave PV as negative. You lose money initially, and you end up with money later. That's why FV is positive. So that is the end of the longest monologue ever. I'll see you around, and I hope it helped.